For example, if we have a superconductor and we have a magnet, and we put the magnet over the superconductor and cool the whole system down, then we take the magnet off and the superconducting disk follows it. And we can rotate it just by hand, and it will continue rotating under the magnet. So we have the magnetic field, which scientists say is frozen inside the superconductor. Well, frozen, the word frozen is not quite acceptable. This is a very interesting phenomena, practically same as levitation, but the mechanism of all these things and the flux and the properties of the electrons, these things are not studied in detail, they are not understood in detail, and even the mechanism of superconductivity, high temperature superconductivity, is not established, and Nobel Prize is still waiting for the scientists who will give us the direct explanation of the mechanism of superconductivity. So it just proves that the subject is too difficult and too unusual to work alone or with a small team. We need the efforts of the international community. That's the key to success.
NASA has an ion propulsion system. Are you aware of that? That particular system, they've got Deep Space 1 and Deep Space 2.
Yes.
Now that are being propelled by that. Have you ever experimented with using gases, maybe like a xenon gas, spinning a xenon gas perhaps?
If we speak about propulsion systems, I think that it's better to refer to another step of our work, which is called impulse gravity generator. And this work attracted not only the attention of NASA, but also the attention of Boeing, and Boeing Phantom Works in particular. They have a special research in this field. So if we refer to this field, this is a bit different, but based practically on the same mechanism. So we again have a superconducting disk, which is made of two layers, but thermal treatment and chemical composition is a bit different, so we have a different crystal structure. And we organize a high voltage discharge through this superconductor. And it's a very unusual experiment. I think nobody in the world ever repeated it. So we use the principle of the Van der Graaf generator, and we have the difference of voltages close to 2 million. We have superconducting material which is cooled, and the whole system is in the vacuum chamber. And during the discharge, again in the magnetic field, during the discharge, the superconducting material emits gravitational wave, or a portion of gravitons, which propagate in space with extremely big speed and are able to provide some pressure or interact with the materials in the area, in the projection area of this impulse. So this interaction is very short in time. It's femtoseconds, or well, let's say 1 million of a second. And we have this impulse which hits the subjects, or all the objects in the projection area, and propagates further, not losing any energy, at least measurable energy. So we began these experiments about 6 years ago, and our first article was published on the net in the year 2000. And this is the theoretical basis of this work was done by Dr. Giovanni Modanese. And this is a very serious research, and it has extremely good potential, because this gravity impulse is able to propagate with the speeds close to 64c, which is 64 times faster than the speed of light. But we have no limitations because we don't work with any material objects. They practically have no mass. And this impulse is able to interact with light. We made rather interesting research. The results were published in the magazine of it's the Journal of Low Temperature Physics in August of 2003, and again it's with Dr. Modanese. So this is another application of high temperature superconductors and the discharge, and the force of the discharge can be rather strong. At first we were able only to work with the pendulums, and just only the best thing that we were able to do was to push a thick book away from the table. It was standing, just a vocabulary. But now when we studied, when we were working with this program for several years, and I have a very good team, we were able to increase the power of this beam, so now it can bend metals, rather thick plates, and it can create holes in fragile materials such as bricks or cement or ceramics. And again, if we say honestly, do we understand in details the mechanism, how it works? Not everything, if not everything at all, but we're working on it. And for the purposes of space research and for the communication, very fast communication, we can definitely use this impulse gravity generator. And we should also study these effects using different approaches, and the most complicated, the most precise equipment that we have available in the world. But we were measuring the propagation speed of the impulse. We used a 2-atomic clock, and we had the distance of slightly over than 1 kilometer. So we repeated these results several tens of times, and I'm pretty sure that we got very exact values. Still, knowing the reaction of the scientific community, or what we call politically correct science, we're a bit afraid to publish the results openly, but sooner or later we will have to do it when we're absolutely sure. And again, I want to repeat that we have no intention to break any laws. And if we sometimes people say, "Oh, Dr. Podkletnev, you are trying to break the Einstein's law," and I want, even with the rotating disks, and I want to remind one more time that Einstein's theory of relativity is good when we speak about relative motion. So every normal motion is relative. But if we speak about the rotation of the object around its own axis, it's not relative motion, it's absolute motion. And the theory of relativity is not applicable to absolute motion.
Obviously, you've worked with NASA a bit. What practical applications do you foresee the future for this knowledge here? For instance, vehicles, instead of on the road, are they up 3 feet off the ground, moving around? Are they space travel? Does this answer any questions of black holes? You know, things of that nature.
Well, I can't say anything about black holes because it's a separate topic, and again, I'm not an expert on this. But if we speak about new propulsion systems, definitely these gravity effects can be used. And even at present, the knowledge that we have, if applied properly, can result in very efficient propulsion systems close to what we call UFOs. Well, in fact, I want to believe that they exist, and I have nothing against. I have never seen one in my life, but from the experience that we have, it's possible to make the objects that will propagate in space using modification of local gravity field, using polarization of vacuum. There are a lot of good theoretical works in this field, and also a lot of practical works. But somehow this is a forbidden area, maybe because there are some traditions in physics, maybe because there are some contradictions. Also, military organizations are always interested in this. Simply, if we speak about anti-gravity platforms or lifters or whatever it is, people say there are some contradictions with physical laws. Well, there are some contradictions, but if we compare quantum mechanics, which is a well-established science in physics, and general relativity, there are enormous contradictions between these two theories, which contradictions in formulas, in understandings, in basics, and the whole scientific world closes the eyes. They don't want to mention it. And by the way, this does not keep people from using both effects. For example, we use Einstein's approach in atomic bombs, and we use quantum mechanics for all electronics and for our portable phones, and both things work, but they have contradictions in theory, and these contradictions are really great. So let's not be afraid of contradictions. It's quite normal. Simply, we don't understand physics well enough, and this is the science which should... it's a subject to evolution. So new ideas, new understanding, deeper knowledge that comes with every year. And at present we have good theories, and in various countries there are scientists who are working in the field of experimental gravity research, and I think it's good to pay attention to those works, because the future of our civilization and the future of modern physics will be in this area, and it's absolutely clear now. Also, gravity will set us free, but freedom is only for those people who think differently. And so we are trying to think differently, and I think we'll succeed in our research. And the history of science proves it, because we had normal phones, then cell phones, and we had primitive calculating machines. Now we have computers. Now we go to space, and practically there are no limits, unless these limits are created artificially. And that's the thing which I'm afraid of. And there is one more saying, that one more interesting thing. People should approach all new changes and all new research fields with open mind, because a mind is like a parachute. It only works when open.